for being in the house. Welcome to my first Space Café 33 Minutes with. It's an honor to start my first series with such a guest. I don't think he needs a presentation, but allow me to give you a bit of introduction before moving to the Q&A. Our guest is Austrian born. He has a master's degree and a PhD in natural sciences from the University of Innsbruck. He has 35 years of working experience at ESA, at the European Commission, at the Austrian Space Agency, at the Asian Institute of Technology, and at the University of Innsbruck. He's fluent in Italian because he spent several years in Frascati, and is also a Grande Ufficiale Ordine al Merito della Repubblica Italiana, which is one of the highest honors that can be granted to a non-Italians from the Italian Republic. Ladies and gentlemen, it's a pleasure to have here with us today the Director General of the European Space Agency, Josef Aschbacher. Hello, Josef. Thank you very much. Benvenuto.
Hello, Emma. Hello, everyone. The pleasure is all mine.
And it's also your birthday. A bird called Wikipedia told me, so happy birthday. And of course, congratulations also for the launch of Ariane 5 that has just been launched successful to you. And of course, well done to all the ESA team. It's always a pleasure to see a very good launch happening with success.
No, thank you. It's the launch is certainly a fantastic element. I mean, we had 116 launches. Ariane 5. I'm sure you have remembered many of these launches, but some of the most significant ones are certainly the James Webb Space Telescope, Christmas Day 2021. I mean, what a launch! I've been there myself, standing in front of this rocket on Christmas Day instead of a Christmas tree, and having the James Webb on top, knowing that this is the biggest space telescope ever built by NASA, more than 20 years, more than $10 billion, very precious space telescope with thousands of people involved, and they have entrusted this to ESA to launch it on Ariane 5. So this was a very special moment for Ariane 5, for us in ESA, but I think for humankind in general, because this space telescope has surprised everyone, and these images which we see are just amazing. But back to Ariane 5. Yes, this was the last launch. We had a German and a French satellite on board, and all flawless. Ariane 5 is known for its orbit precision, or injection into the orbits very precisely. And I'm feeling a bit sad, to be honest, because it is such a wonderful rocket which is now retiring.
Well, nothing beats us a good lunch. So it's always emotional, and I'm glad that we live a time when we can see these things happening more and more. So it's fantastic. Before we launch into the interview, I want to thank all the SpaceWatch.Global newsroom team that has helped to craft this interview. When the people knew that we were interviewing Josef, a lot of our collaborators, Chris and Steven, they just pitched in. So I want to just pay credit to the teamwork, and Torsten, of course, that has been behind this interview, which means that if you feel that the questions are too mean, Josef, then you know that you have to blame someone else. It is not me. Okay,
it's not you.
Exactly, it's not me. Let's get started. So the BBC is helping us to get started this interview because they just published a few weeks ago an article titled "Global Warming Set to Break Key 1.5 Degree Limit for the First Time." It was just a few weeks ago. I'm happy to share the link with everyone. The title says, "Our overheating world is likely to break a key temperature of limit for the first time over the next few years," scientists predict. And the BBC called this a warning sign that warming is accelerating and not slowing down. I think this is setting the stage and kind of give you a hint of where I'm going to go with this first question. I want to pick up on this, and I want also to connect our oldest discussion from GLOC. We met a few weeks ago in Oslo. GLOC was for those of you that don't know, GLOC was one of a kind interview conference where we start to discuss about space directly linked with climate change. But there was one of the criticisms of GLOC was that the space domain seems still a sort of an observer, a provider of data, but it does not transform this data into actionable information that can actually inform policymakers or what needs to be done to limit climate change and stop its root causes. So I wanted to ask you, what's your position on this, and how you think the ESA can move from a position of data provider to the position of solution provider?
Yeah. No, I think this what you're mentioning here, Emma, is very relevant, and it's extremely important. I mean, of course, you first, in order to make good simulations, good predictions, a good understanding of our Earth system, that means really the atmosphere, the oceans, the land surfaces, how they interact, which is quite complex, as you can imagine. To understand all that, you need good observations and good models. And these good observations really come from space. It is fair to say that without space observations, or observations with Earth observation satellites in particular, you would not know the state of our climate to the extent we know it today. About more than half of the so-called essential climate variables, which are defined by the global climate observing system, are coming from space. Examples are concentrations of CO2 or sea surface temperatures, sea level rises, sea level height, but also a state of the ice caps on the North Pole, on the South Pole, and the melting, how this develops. So all these parameters that define our climate are measured every single day, every single minute, by the way, from satellites and also on the ground. But satellites are providing the key input to this data. Let me take a similar example, which is weather. Of course, weather and climate are related. It's just a different time scale, but the Earth system modeling is the same. More than 80% of the observations needed for meteorology, for weather forecast, come from satellites. And for climate observations, very similar. The input of our data from the ESA satellites are essential to really make sure that you know what the state of the climate is. All the reports that have been prepared by scientists that confirm or that establish this 1.5 degree target actually are based on a lot on satellite data. And this is well recognized, and thank God there's no more climate doubters that say the climate is probably not a reality, but the evidence is showing it very clearly. So yes, on one side, you're absolutely right. We have done a lot to establish the measurements and the observations, and that is a starting point, because without that you cannot go any further. But what we're doing more and more, and this is something I actually started a few years ago, exactly the same question which you had, I was asking myself and then discussing with my team is, look, we are so good in observing. What do we do next, and how can we go from observation towards action, and what is needed to get there? So this longer brainstorming and discussion led to something that I call a digital twin of our planet, digital twin Earth, where we combine observations from satellites with geophysical models, climate models, together with using, of course, artificial intelligence, modern computing capabilities, also high performance computing. And based on this, we create a twin, a digital twin of our planet or certain parts of our planet in order to simulate a situation. Let me be a bit more practical. All or most countries in Europe have committed to being climate neutral by 2050, which is, of course, is a very ambitious goal in order to keep climate change under control. In order to do that, of course, you need to convert your economy, transport. You need to go from one fuel type into a next one, for example, from diesel-driven cars to electric cars, from one energy source to a more renewable energy source, wind, photovoltaics, hydropower, and similar ones. So in order to know what is best for a country, you can simulate with digital twins, first of all, to assess the situation, and then have what-if simulation. So what happens if I change something, if I change, let's say, all the coal power plants to be converted into some renewable energy sources, or if I do it in 10 years or in 5 years from today, what is the impact on climate, but also on people and the economy? So these digital twins not only look at the climate parameters, but also the socioeconomic parameters. What does it mean for the economy? What does it mean for the people? Who is affected in this area? Is it only people in the big cities or in the countryside or a mix of it, and so on and so forth. So there's a lot of parameters you can simulate. If you're living, for example, on the coastline, you can simulate climate change or the impact of climate change, which is causing sea level rise. So what does it mean for those houses along the coast? Which ones are affected? Which ones are flooded? Which ones are in danger? And it's not only the sea level rise itself, but also the storm floods, which of course are more intense with higher winds, and therefore the waves that are being brought towards the land surface are much higher and therefore endangering much more areas. So all this can be simulated with 3D models, of course, of our landscape, land use maps, expositions to the sun, expositions to wind, and so on and so forth. And this you can really use to make, to simulate, and then based on these simulations, create actions or define policies that need to be developed. And this is at the core of these digital twins. I've actually asked my team in-house in ESA to simulate or to develop one of these digital twins on one small country called Austria, because they have a very good data set of in situ measurements. That means ground-based observations. We use the space data on top, and then we simulate for this country. What does it mean if you put windmills? So that means power plants based on wind, or photovoltaics or on different places. How far away should they be from populated areas? Which exposition of the landscape is important, the height, the slope, and of course the orientation on towards the sun for the photovoltaics, but also the houses, the roofs, and so on. So there's many parameters we are looking at, and then you can simulate what happens if I do this, what happens if I do that. And this, of course, you can translate into action, either action for industry to invest, or for policymakers to make decision or prepare even legislation. And I think this is very powerful. So my goal is that this digital twin, which we did for the case of Austria, which is a pilot case, that this can also be applied to other countries. Actually, some countries already have expressed interest to do it in their home country. And this is one model, one way of where and how we can use these observations together with digital twins into action, and how this can really help people on a daily basis.
Thank you very much, Josef. You mentioned policymakers. Are we doing enough to communicate all what we're doing, all the results we're having to policymakers, to decision makers, to the government body? Because one of the issues that we notice in several space conferences at Glock is that the political class seems not really on the boat yet. It seems they're not particularly interested, or there are other priorities. Is the link between what we are doing as a space industry, what ESA is doing, and the government a solid link, or we still need to work on it?
Oh, we need to work a lot. And actually, webinars like the one we're having right now are hopefully also contributing to the dissemination of this knowledge. But you're absolutely right. A lot more has to be done. And I always discover when I talk to decision makers, to the general public, to politicians, when I explain what space can do for their particular problems or for businesses in order to help them creating a business case, that very few people know about space, really what space can do and how much it can contribute to their particular situation. Actually, there was one interesting encounter I recently had with the CEO of a major consultancy company, McKinsey to name the name. And Bob Sternfels, and he said to me, because we met a few times, and so we have a bit of a casual discussion. And at one point he said, "Look, Josef, I'm so fascinated by space because space can do so much more than it is doing today." And of course, companies who are giving consultancy advice to all kinds of disciplines, from pharmaceuticals to transport to energy companies to tourism companies to medical companies. I mean, all kinds of market segments are being addressed, and they are, talking to CEOs in Shanghai, in United Arab Emirates, in Saudi Arabia, and of course in Europe, in America, in Latin America, to all kinds of major companies, and they really have a very good overview. And he said, "Look, I have discovered, because we have done an analysis, and we think that space is one of the future technologies that you have to invest for a company to be successful. So he said, when I meet a CEO of a big company, or pharmaceutical, for example, I would ask them, are you using space in your company? And most of them say, look, what should I do with space? This is very exotic and is not for me to consider. I said, no, if you're not using space in your company, you may actually miss out and you may not be ready for the future. You should apply and you should use and think of space as one of the elements where your business can grow, or where you are using information or testing technology that can be done in space, and you should do that. If you're not doing it, your business may be in trouble. And I think this was so eye-opening for me, not this being said by me as Director General of ESA. Of course, if I say it, people say, yes, of course, he would have to say that because he's from the space domain. But other people who are not in the space domain, looking at us from the outside and assessing the various opportunities, and these kind of words from this kind of people are very powerful and very eye-opening. And I think this is really showing that space is completely underutilized in many segments of the economy and society.
So very interesting point. Picking up on just what you say, what can space do more? Going back to our climate issue, I think, I'm going to expose my theory and you can agree or not agree or disagree with that. When we speak about climate change issues, we are observing the necessity to apply a profound transition to our entire system. Like the electric car is just the tip of the iceberg somehow. So when I speak about system transition for climate change issues, I mean a profound societal inversion that tackles how we live, how we eat, how we work, how we bring our kids to school, how we produce energy, of course. So can space help and support to tackle this massive societal transformation, such as facilitate, of course, the transition from fossil fuels to renewables energy, but also a transition to a sustainable food system? We know the agriculture is a massive issue. Of course, the big issue of private transport, or how we build our houses, how we move. Can space practically, with practical examples, support these sectors where climate change is still a problem?
I mean, the short answer is absolutely yes. It can do it, and it is doing it already, because space is so underutilized today for many aspects of daily life, and it is absolutely necessary to really expand the use of space into those segments where climate change in this particular case is a major issue. And this really goes from political elements to economic aspects. Other important aspects, of course, are the ones linked to security. Security, not only in the sense as we see it today in the war of Ukraine, but also much wider. If you take the African continent as an example, because of climate change, certain areas are having long droughts. Food security is at risk. That means they cannot feed the population, or there's not enough crops that are growing for climate-induced reasons. And therefore, these people need to move. If there's no food that can be provided, people are moving. And that, of course, triggers stress between countries. Access to water is a very critical element. It triggers migration, and then suddenly the climate change issue in somewhere in Africa becomes a security issue, or becomes an issue also of political discussion in Europe. And this is something where we see this global connection, first of all, of impacts of climate, but also how climate, of course, affects very strongly the life of people. And again, coming back to space, yes, space can do a lot in order to, first of all, have a global picture of what happens. Secondly, as I said before, to simulate situations and therefore help in better estimating what's about to come. And third, take action in order to prevent some of the crises that might be caused by climate change. So yes, space is playing in all these elements, from monitoring, adaptation, mitigation of climate change effects all across this cycle.
Thank you. One day I will want to explore more this take action with you. Today there is no time, but I think it's worth it to try to actually pin down which type of action we can do. But I want to move on the moon, because the moon is also, of course, another huge topic for ESA, for the entire space community. So there are numerous visions regarding the use of the moon. Some view it as a potential investment opportunity. Some think about the moon as a sort of harbor, a new gateway just to go to Mars. Other project, this seems indicating the idea to use the moon as a sort of waste disposal, a giant big industry where we move everything that is dirty and unclean on Earth. Some others think about it as a sort of new Klondike, a colossal gold mine full of helium-3. What is ESA's vision for the moon and its resources? What plans does ESA have for harnessing these resources?
No, I mean, all the examples you mentioned are certainly the ones that are being discussed, and many more. You can imagine that there's a lot of research done of what happens on the moon, how the moon looks like. But certainly one element is not on our horizon, which you mentioned, which is using the moon as a dumping ground for waste, which you don't like on planet Earth. For us as ESA, the moon is of interest for many aspects, certainly driven by curiosity, research, technology, innovation. This is what ESA is doing, and this is what we're doing also when we want to go to the moon and when we want to set up a base or infrastructure on the moon. So what are the options? And certainly much of it we don't know yet, because if you do exploration, by definition, you do not know what you find there, because otherwise you wouldn't explore. You would just go and do what is already known. So certainly there's a huge element of discovery, of research that drives us as ESA, where we want to investigate what is there. There have been quite a few missions that have been mapping the moon in terms of resources, and we do expect quite a few of them. Among them, there are rare earths, there's regolith, we know there's water and ice on the South Pole, which of course has a lot of potential for energy production, but also the regolith. We have models and experiments where we want to use regolith with 3D printing to construct infrastructure, houses, research facilities, and so on. So there's a lot of different elements that are being expected, and of course then building up an infrastructure on the moon. That means an infrastructure to use the resources there, but also to interact with other players, other partners on the moon is important. Let me take another example of a project we started in November last year called Moonlight, where we are preparing a network of satellites around the moon that will offer telecommunication and navigation on the moon surface. In other words, if you need to monitor, or if rovers or astronauts want to communicate on the moon between them or with the gateway or even with the Earth station, you need communication, a communication network, just like on Earth, where you use your mobile phone for communication, whether you are in the US or in Europe or in Asia. There are global networks that allow that. And on the moon, exactly the same problems. You need to communicate between different points. You need to navigate for your rovers to find new areas, or for the astronauts to make sure that they are not getting lost on the moon and therefore finding their home base, and so on. So there are many examples of technology that is being developed, and even commercial services that are being built up. For example, in telecommunications and navigation, we would expect that in a couple of years, when this service is established and running, that there will be users who are paying for it and who are using it for their exploration activities. So yes, the moon is full of surprises for sure, but also full of potential that we want to explore. And our objective as ESA is really to do all the exploratory part, the research, the technology development to get there, but also the establishment of infrastructure. And then, of course, we do this with private industry, hoping that they will then also invest on their side. And of course, they then build up the infrastructure medium to long term. But our job really is to do the pioneering work in order to prepare the ground, prepare technology for then others to follow and really come onto the moon.
I hope you're going to say if you need to call it Uber on the moon, you can use Moonlight. Okay, last 4 or 5 minutes, I want to shift a bit on global policy. If I can, kind of squeeze in a couple of questions. The first one is the never-ending question about the comparison between Europe and the US. I know that this is a question that I've asked and many people ask you several times. So I want to try to change a bit the perspective. We all know, we understand perfectly that Europe might not be able to outpace the US or China in the short period. But I believe that we should also try to ensure that we don't fall behind. So which countries, so excluding the US, excluding China, which countries serve as a reasonable benchmark for Europe? Which nation we should monitor closely and compete with just to maintain our edge, our competitiveness?
Well, this depends very much on the domain you're looking at. If I take some of the domains where Europe is really good, there we are among the top players, like the US, like China you mentioned. I take Earth observation as one example, with Copernicus, with the Earth Explorer missions, with the Scout missions, with the meteorological missions which we are developing. We are among the best in the league, and some people even say that we have developed the gold standard of Earth observation through the Copernicus and Earth Explorer program. So certainly there, Europe is extremely good. The same for navigation. Galileo is today providing the most accurate signal in the world. The accuracy of the navigation position based on Galileo is higher than any other system. The same in space science. In space science, we have top scientists, as science groups, but also top technology that we are deploying. Take JUICE or Euclid as 2 examples where we have launched missions just this year within the last couple of months. Both of them extremely exciting, extremely fascinating what they do. On one case, looking at the icy moons of Jupiter for their habitability, whether there is life or could have been life on these icy moons. On the other case, looking for to understand dark energy and dark matter. I mean, absolutely fascinating if you think that only 5% of our universe is visible and we can understand, measure, and see. And the other 95% we cannot see and we cannot really understand. We just assume that there is some matter, dark matter, as we call it, or some dark energy that let us explain the phenomena as they happen in our universe. So these are fascinating missions. So in these domains, we are really good as European industry and, of course, driven by ESA. In other domains, and there I would say we are at the same level as the US, China, or US and China certainly having the lead on those. Then in other domains, of course, we are not at the same level. I take launchers, where, of course, we have a domination from US private companies, as you perfectly know, and I don't think I need to explain. But also in exploration. Exploration means sending humans to the space station and beyond, to the moon and eventually beyond. There we have excellent technology, excellent capabilities, but they are much smaller than those, for example, of the United States. Europe spends 1/15 of the funding of the United States, of NASA. And of course, with 1/15, you are limited in your capabilities, and you can be wonderful, but of course, with the limited amount of funding, you cannot be at the same level. What we do it very well, and we are a very strong and good partner of NASA, for example, on the Artemis mission, the European Service Module, but also the Gateway with IHAB, ESPRIT, and other activities are very strong contributions on which NASA is relying, and I'm very proud and very happy on those. But on some things, we are not at the same level, and I take human spaceflight as another example. As you know, today it's the US, China, Russia who can bring astronauts with their own rockets into space. Soon India, in a year and a half, we expect India also to be capable of having their own astronauts flying to space on an Indian spacecraft, but Europe cannot. And this is for me a big question, why Europe, with all this excellence in technology, is not at the same level. And this is something I'm promoting, as you certainly know, very strongly. I'm asking these questions to decision makers and to society. And actually, this is quite fascinating, because when you ask this question, this is questions that have been addressed by not only space experts, but also experts in the society. And they pretty much say Europe should wake up, should reconsider its position on human spaceflight, and see what can be done, because there's so much benefit that goes way beyond the space segment. Take geopolitics as one case. Just imagine we can fly, Europe can fly a European astronaut who is the commander with an African, and a Latin American, an Asian, another American on a European rocket and capsule onto a space station, or eventually to the moon. I mean, this is fascinating, but also very powerful in terms of forging cooperations internationally. And Europe classically is a collection of countries which cooperates with many other countries in the world. And I think this is something very powerful. But also the economic aspects on the space station. There are many opportunities in many domains which are opening up in microgravity, but also STEM, to have young talents staying in Europe, or others coming into Europe and working on very exciting projects. So that's something that is quite important. Uniting Europe in terms of countries and capabilities is also important, and big projects unite Europe. And I think there's so many aspects which are going way beyond the space sector. And yes, that's something where Europe really has to catch up. And there, if coming back to your question, where we are in this level, if we talk about human spaceflight, there we are certainly, I would say, in the ranks of number 4, number 5, roughly, while in other domains, Earth observation, navigation, space science, we are certainly equal with the other major countries, US and China.
Fantastic. Josef, I'm going to move to the question of the audience. Thank you very much. We have in the first question from Gunjan of Go Emerald. How can small businesses engage with ESA on this effort with data? And I think she's specifically addressing the digital twin concept that you explained in the beginning.
So just to perfectly understand your question, so how can ESA?
How can small business engage with ESA on the effort that you are doing, gathering all this data to produce the digital twin?
So there's a lot to be done for small businesses. Of course, the whole conception is an activity that needs to be organized, I would say, pretty homogeneously to make sure that we know where we're going and what's happening. But then actually the implementation of many of these aspects is done by businesses, big and small. And actually, the small ones are quite interesting because they're very agile, very dynamic, very fast, very innovative. And that's exactly the concept that we are promoting also in this digital twin. So we have actually elements, for example, writing pieces of software to simulate sea level height and the impact on people on the coast, or writing other pieces of software to simulate the impact of air pollution on health and what this means for the medical sector, and so on. So there are many of these domains where especially smaller companies are active. And yes, that's what I want to do, actually, based on these observations of the investments which the public made, ESA, European Union and member states, through Copernicus, for example, where we have literally invested billions to build up the infrastructure, now to offer opportunities for small and medium-sized enterprises to really hook into these observations and convert them into services and business models. And that's exactly what I want to promote.
Thank you. Next question is from Valentin, a bit of safety question on the moon. In the case there are people working on the moon, are there any rescue plans to bring them out? Fair question.
Of course. I mean, we're not leaving the people on the moon if there's an issue. No, absolutely. One of the fundamental architectures is, of course, the return flights and all the safety measures that are linked to it. You can imagine if there is really several, I would say, players working on the moon, that there will be a need for reciprocity in terms of rescuing a member from another country or another space agency, and be assured that we're doing everything to bring people safely back once we fly to the moon.
Bernd, Josef, we do see an unprecedented demand for launches into various Earth orbits and beyond, both for scientific payloads as well as commercial payloads. We have heard for decades that Europe needs to have an independent access to space. This is a question that you knew was going to come. However, these days, Europe doesn't have such an access to space, as Ariane 6 and Vega isn't available. What are the political consequences regarding this mess, and what are the lessons learned?
Yeah, no, I hear this question a lot. Believe me, especially these days, you're not the only one asking this question. But you have to put, it's true that for some months we will not have independent access to space, and I'm committed 100% or 150% to ensure guaranteed access to space. This is a top priority which I'm doing. But of course, sometimes you have to step back a little bit and see it from a distance. First of all, when Ariane 6 will be up and running and Vega C is back on the launch pad, this few months which we have without a launcher will be a blip in the history of a long series of launches. I just mentioned that we had 116 launches of Ariane 5 over more than 20 years, and very successfully. Of course, now we have a situation without, and you really have to step back and see this a bit in the wider, longer context. Also, if people talk about launchers, I just mentioned that in many other domains, I would say in almost all the other domains, Europe is doing extremely well in space. I mentioned Earth observation, I mentioned telecom, I mentioned navigation, and many, many others. We're doing extremely well. Of course, launchers today, we have a challenge to solve, and this is normal business that we have to address them full speed, full energy, and that's exactly what we're doing. Believe me, I've done quite a lot to put management actions in place to go to the bottom of the problem. And yes, we are on top of it, but of course it takes a couple of months until we have again regained access to space through our own rockets.
Do you have a couple of minutes, Josef, that I can
Yeah.
steal? Okay, fantastic. Good. Let me know when you have to run away, because of course we have many questions. Andrew Williams, given the industry and ESA member state form a sort of special type of closed market, can ESA use its institutional weight to create hard requirements for sustainability, for example, by introducing standards in future commercial procurements? That's a very interesting question.
It's a very interesting question. I like it a lot. Actually, I just had a meeting before this meeting here, so before this webinar, with one of these new space companies. Don't want to mention the name just to not promote one over the other. But their idea is fascinating, and they are looking at ESA to help them realize it. And I can say what the topic is. The topic is to transport cargo into space with a spacecraft, and then not only transport it there, but also re-enter, so that you can use microgravity in space for a number of applications in research, but also in material sciences, in pharmaceuticals, in medicine, and then bring these samples back to Earth, and then of course use them on planet Earth with the results of microgravity. So this company is one of a few that is working in this domain. Fascinating ideas, fascinating technology they're doing, and of course they want to work with us where we are the anchor customer for their product, of course, to help some technology development in terms of technology building blocks that are needed. But first and foremost, they look at us as an anchor customer, that we really buy a payload or buy a service from them, because with that service, and of course we will do a lot of evaluations and analysis from a technology point of view. But once this service is bought by ESA, they can then go to a funding company, venture capital company, for example, and then acquire fresh money from outside in order to continue the development of the activity. And that's exactly a model which I'm promoting, because we are, of course, developing technologies from the ground to build satellites, but also more and more we will act as an anchor customer to really encourage new companies to develop their own innovative products, where we are a customer and they really take more risk, also acquire funding from outside, but we play a very important role to co-engineer and be a partner in this undertaking. And that's a new role of ESA. I'm very committed to develop it and to bring it forward, but I think this is really something we have to reinforce quite significantly in the next couple of years.
Last two questions. Catherine asks, how can we get world leaders to take action to safeguard the security and sustainability of the space environment, which is increasingly under threat? Great question, Catherine.
Oh, yes. World leaders, of course, are the ones that make world or very important decisions. But I have to say that climate change, of course, is now an extremely important topic in almost all the countries. The use of space for climate change, as I explained also before, is really recognized. And I think more and more we are actually getting access to top-level politicians, heads of governments, head of state in different countries. And yes, this is something that we need to intensify at all levels. Certainly ESA can do some part of it, but also every single citizen is a voice towards these causes to make sure that we use our space technology in the best possible way to basically save our planet. And yes, absolutely, there needs a lot of work to be done.
Need to knock on the doors, because what I learned is that they don't come to us. We need to go to them. This is one of the feedback.
Absolutely, yeah, absolutely. Yeah.
Last question is bringing the attention on Solaris, a project that we have been following very closely because we're really interested in space-based solar panels. Christoph is asking, what are the odds of space-based solar panel power picking up a substantial share of fossil fuels-based energy production? When we speak about ESA, of course, Solaris project.
Yeah, this is something that excites me a lot. I have to say, though, to be fair and to be correct, this is a technology where we think the potential is enormous, but we do not know today whether there are major, I would say, stumbling blocks or major blocking points in order to realize it. And many of it is connected with the size of it. Of course, that we know that you can transmit energy from space to the ground. We're doing it since many decades already, but it's the scale which we're looking at. We're having models where we would like to produce 2 gigawatts of power in space based on photovoltaics. The extension is enormous of these satellites that are collecting this. Then, of course, the transmission down to Earth and also the receptors, the detectors down on Earth are very, very large. And in addition to the technology challenges, there are regulatory issues and many other things. So we're doing a feasibility study right now with some technology testing. I've obtained some seed funding from the member states at the last ministerial, but I would like to prepare to have enough knowledge and enough substance to then decide whether we prepare a real project for the next ministerial or not. And this, of course, depends on the outcome of the next work. In short, the potential is huge, and it would then really convert our fossil fuel crisis into a very positive one where we have renewable energy to solve it. Also geopolitically, you can imagine this is extremely attractive because we wouldn't depend on external countries because this, to some extent, of course, energy would come from space. But there are huge challenges ahead, and I cannot give you an answer today whether this will happen or not, because we are very seriously looking into all the aspects of technology and regulation.
Well, we're a big fan of Solaris. We are declared fans of it, and we actually interviewed Sanjay, I think, more than once from ESA. So we're looking forward to know more. And okay, I'm going to close it because we're already, of course, late, and the Germanity of Thorsten is making me sweat because I know that we have to close it here. I thank, first of all, Josef, thank you very much for your time, for the completeness of your answer. For us, it's been an honor to have you here. It's been a pleasure to interview. And I thank everyone in the audience. I'm sorry I've not been able to take all the questions. There were too many, but Thorsten, are we going to be able to send them to ESA to have to somehow, so at least we can satisfy the curiosity of our audience?
Yes,
okay.
I will send it to Bernard, and then we see what we can get from him.
Thank you very much. In the meantime, I thank also Thorsten and all the SpaceWatch.Global production for following me and giving me the opportunity to stand on the stage of Space Café, 33 minutes with, such an honor. And Thorsten, over to you. Josef, again, thank you very much, and I'm looking forward to see you to the next conference.
Well, thank you. It was a real pleasure, as always, and I'm always very happy to talk to you. Of course, your SpaceWatch Café is a very good forum, and it's always a pleasure talking to you.
Thank you very much. Thorsten, over to you.
Thank you. Yeah, just briefly. And Emma, you went so quick into the 33 minutes today that you didn't mention our podcast. So the latest episode of the Space Café podcast with the wonderful Barbara Belvisi of Interstellar Lab in her conversation with Markus Moslechner, or that we have new radios from Glock, the last one with Aina Björgo, the director of UNOSAT, and of course with the MEP Niklas Ninas, who we met the last days in Brussels. He is an MEP, is a member of the European Parliament, and then really a huge advocate and fighter for space in the European Parliament. And to everyone who is listening, please support Niklas in his endeavor. I mean, that's what we can do because he's one of the very, very few voices for space in the European Parliament. I think, Josef, you can agree to that as well. So, and we have also the latest episode of our Space Economy Insight podcast with the wonderful hosts Kevin O'Connell and Dr. Emma Gatti with Matt Gilliam from Australia. So, but before we say goodbye, we just want to remind you to a few of our events. You see, it's very thin, so we will take now the next 2 weeks, bit time off. And then on the 27th, we will start in the morning with our Space Café Law Breakfast with Stephen Freeland, and Stephen and I will host Axel Cartier and Dr. Ingo Baumann in our breakfast. And on the 27th as well in the afternoon, we have our next Space Café Benelux by the wonderful Heike Pongyan, and she will talk about with her guest about quantum computing in space, something like that. Something what I don't understand, but that's why we have Heike. And then one day later, we have our Space Café Israel with our wonderful Medad Payente. And of course, we only have wonderful people that run our Space Cafés. And we are almost done. Yes, and as usual, all these events are online or will be going to be online on Eventbrite. And we would like to hear your feedback, so please check in with us on Twitter, on Facebook, or on LinkedIn. Don't forget to sign up to our daily or bi-weekly newsletters. And if you like to treat yourself with something special, become a Space Watcher today or get one of these wonderful mugs or anything else, but help us. Please help us to do and continue our job. Thank you, Josef, for this really insightful talk and for being our guest today. It's a great honor. It was a great honor to meet you yesterday in Brussels and today in our sphere. So that's to have you in our house and on your birthday is really something special. Thank you for our audience, a huge audience today, for joining us. And I hope to see you in the next events, in the next weeks. In the meantime, visit our website or follow us on social media. Take care and don't forget, become a Space Watcher. Thank you very much, everyone.
Happy birthday.
Thank you.
Bye.
Bye-bye.